Yeah.
Introduce yourself.
Yeah, first of all, good evening to all. I am Pankaj Kumar from Aurangabad, Bihar. As my education qualification is BTech from RBS CET Jamshedpur with Triple E department. I have completed BTech in 2022. After completion of BTech, I am joined the ARF Design Company. To since I have had 3.2 year of experience in analog layout design engineer.
Uh, okay.
Thank you.
And okay. And so you have worked in 3 nanometer as well as 45 nanometer. So what is the difference between them?
Yes. Actually, 3 nanometer is lower and FinFET technology, and 45 is planar.
Okay. Uh, can you more explain about a DRC rule and NVS rule for 3 nanometer and 45 nanometer?
Yeah, actually, I'm run the DRC of in 3 nanometer TSMC tool with a TSMC tool of caliber ICV, Synopsys ICV, and here spacing of the metal and base is minimum related to 45 nm.
Okay. And what about restrictive spacing enclosure rule 3 nanometer?
Yeah, enclosure rule in 3 nanometer is a metal enclosure. Uh, uh, Actually, a metal phone to via is 0.005.
Uh, okay. And check it that there are some restrictive spacing and enclosure rule at 3 nanometer. And check that.
Yes.
And
Generally, metal. क्या है?
हाँ बताओ.
Uh, Generally, metal spacing according to 3 nm DRM, metal 0 minimum spacing is 0.014, and metal 1 is 0.02, metal 2 is 0.02, and last metal suppose M15 is maximum width of 0.062.
Okay. And mm, oh, uh, what problem did you face in 3 nanometer technology for DRC?
Hello.
Hello, am I audible?
Yeah, but your voice is jarring. Uh,
Okay. What are the problem you face in 3 nanometer technology layout?
During
3 nanometer technology layout.
sorry.
What problem you have faced in 3 nanometer technology layout?
3 nm technology layout. Generally, DRC issue is come in 3 nm related to 45 in 3 nm space is very less.
Huh.
So in routing, metal spacing DRC is come.
Okay. Uh, and how have you removed and how you did floor plan for small nanometer technology?
Sorry, please repeat again.
How you did floor plan for 3 nanometer technology?
Generally few days ago I'm do a floor plan of TSMC TSB cell. Uh,
Okay.
so this cell HBM is placed in right side, and driver and pre-driver is placed in middle, left side.
Okay. Um, do you know the difference about analog layout floor planning and digital layout floor planning?
Then generally, I'm do analog layout floor planning, but a little bit of knowledge in digital. Generally, in digital layout, spacing and area is very less as compared to analog layout.
Mm.
Or generally in a digital layout, a standard cell and a logic block, digital logic block is most of the time is repeated, and in analog layout, uh, generally analog circuit like DAC, ADC, DSC, and band gap is present.
Okay. And
Generally, main difference is spacing.
okay. Do you have experienced any mismatch problem in layout?
Yes. Actually, when I'm doing one block, here mismatch error is comes. Generally, finger mismatch is comes. Suppose in schematic, I have a four finger mouse, but in layout, in layout, four finger mouse is present, and schematic designer is changed, and its value is three fingers. So in this time, I'm facing a mismatch error.
And how would you resolve that?
According to the LBS report, I'm go in schematic and check schematic most, and talk to designer and change the value of finger
No,
in
not in
schematic.
LVS. Not in LVS. In DRC, there are different types of mismatch. Not in LVS or DRC, in layout planning.
Yeah,
When you place transistor
in layout.
in post,
Sorry,
okay, just check the systematic mismatch and random mismatch, what happened in layout and how to resolve
yeah,
that. Mm, okay. Do you know about
yes.
centroid layout and structural layout?
Centroid means matching type of matching,
Yes, yes,
or a
matching.
different topic.
Nee,
Yeah,
nee,
matching.
matching.
Yes, generally two type. Yeah, generally two type of matching in layout, analog layout, common centroid and interdigitation. Most of the time we use interdigitization. Generally, in interdigitization, half cell is created A B and B A.
Okay.
Uh, yes, generally diode connection and input pair device is match with common centroid method.
Okay. And what is fingering? Finger in layout.
Yeah, finger. Suppose device means in any device one poly is present. So finger is one. Suppose two poly means finger is one, and according to the one finger device connected in parallel, so then finger is fourth.
Okay.
Means define and poly. Suppose one poly is present means finger is one. One poly device is present, active poly means finger is one.
And what is polish sharing?
Sorry, repeat again.
Polish sharing.
No, your voice is not clear.
Hello, am I audible? No. What is polish sharing? 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 . 。 。 . 。 。 . 。 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 . 。 . 。 .
。 Sorry, your voice is not clear. I think internet issue.
Hello, am I audible now?
Yeah, yeah,
What
yeah.
is polish sharing?
Policy sharing. Yeah, yeah. Suppose able to device and get is common. Sorry, policy sharing. No, no, no. Your question is policy sharing. Hello.
हाँ, polish sharing.
Sorry, sorry, sorry. I
Uh,
don't know.
okay, check it. Just like for area management, sometimes we used polish sharing for like memory and log layout design. Okay, now tell me uh, what is half DRC in layout? Hello, hello.
Ah, yes.
Do you know about half DRC in layout?
Yeah, yeah. Generally, employ in a standard in logic they get in logic get half DRC we follow. Suppose in any metal DRC minimum DRC is 0.022, 0.022. And this block is repeated. So I'm in lower cell I'm means in lower cell I'm back hierarchy I'm use 0.011 DRC because in next level he about and 0.011 and 0.0111 both is mm, both is means both addition is 0.022 and DRC is clean.
Okay. And do you know latch-up protection?
Yeah, yeah. Generally, latchup is defined as the existence of low resistance path between BDD and BSS. And BDD and BSS and and LASEP create a short circuit between BDD and BSS. Generally, in BDD and BSS and PMOS and NMOS, LASEP create the SCR and SCR due to this SCR leakage current short the power and ground means PMOS and NMOS.
Hmm. Okay. Just uh, used to explain through diagram the latch problem and
Uh,
what technique we use to resolve this latch problem.
Generally, double guarding is used to reduce the latch up problem.
Sorry.
Sorry, generally, double guarding is used to prevent the latch up.
Okay. Or tap cell.
Yeah, tap cell and tap cell also. Tap cell is used for digital cell. Yeah.
Yes. Um, how do you handle IR drop or electromigration in layout?
Generally, yeah. Generally, in main, I'm do increase the width of the metal, and
Mm.
next is metal stacking and parallel routing. Most of the time, we use the parallel routing.
Mm, okay. And uh,
Yes.
for routing, which metal is used for no for which signal higher metal layer is used and for which signal lower metal layer is used.
Generally, a sensitive signal is used in higher metal. Means those signal required lower resistance path. So we use higher metal, and a normal signal we use lower metal. Generally sensitive signal and more high speed signal or power signal we use route higher metal.
Huh. So for a clock.
Yeah, clock in clock also use higher metal. Because the clock is a more noisy signal and need to reduce the resistance of the path.
Hmm. And which metal layer have more resistance?
Sorry, repeat again.
Which metal layer have more resistance?
Generally, lower metal have more resistance.
Okay. Uh, use of deep anvil in your project?
Yeah, yeah. I'm using deep anvil. Generally, deep anvil is isolate between local substrate and global substrate. Means suppose I have a two NMOS. One bulk is suppose DSS and one is different. So in this time I'm use deep anvil in one NMOS because deep anvil is separate the substrate of NMOS from the other substrate of NMOS.
Okay. And do you need shielding for in your layout?
Yeah. Generally, sending M to protect sensitive analog component from external electromagnetic interference and noise. More some signal suppose some signal name just suppose a clock signal, data signal, high speed signal and reference signal and need shielding because signal are these signal are sensitive signals.
Okay. Mm. And guarding, have you used that?
Yeah, use guarding. Generally, in analog signal, in analog layout, a single guarding is used, but most of the time means in any device latch up and OD injector issue is come. So double guarding. In this time, double guarding is used.
Okay. And what is your experience with multi-VT cell handling?
Sorry,
Multi-VT cell?
no, no. I am not experiencing multi cell.
Okay. Mm. Why we need a dummy cell?
Sorry, repeat again.
Why we need dummy cell? Hello? Do you know dummy insertion? Hello? You are mute, I think.
Sorry, sorry.
Okay.
Yeah, yeah, need a dummy insertion. Generally, I'm doing one block and antenna is come. Uh, this time I'm using dummy insertion because I need to increase the gate area. So insertion of dummy and by help of insertion of dummy increase the gate area and antenna reduce the antenna effect. And
Okay. What are the other technique to reduce antenna effect?
yeah, metal jumper and antenna diode also used to reduce the metal jumper antenna effect.
Mm.
Generally, most of the time, metal jumper is used.
Okay. And do you have face any problem for a metal jumper in layout?
No, sorry. Most of the
Something
time I'm
like
use
a
metal jumper.
hammerhead problem.
Sorry, repeat again.
Hammerhead problem.
Yeah. Hammerhead program is come of metal jumper. Use of metal jumper.
Okay. Mm. Difference between via and contact.
Yeah. Generally, contact is placed in diffusion, and he defines the source and drain terminal, and via is connect the other metal, some routing
Mm.
metal.
Huh. For source to drain connect, which one is used? Contact or via?
Source to drain connection.
Huh?
Source to drain connection. I think via is used.
No. Contact it will use.
Okay, sorry.
Mm. And for poly to routing,
Poly to routing via is used.
no contact.
Okay, thank you.
Only metal to metal connection is for
Via
a
is
global
used.
interconnect, via is used.
Okay,
Mm.
yes. Next.
Okay. Yes. What is diffusion layer?
Sorry, repeat again.
What is a diffusion layer?
Diffusion layer.
Hmm?
Generally, OD is a diffusion layer.
OD diffusion layer. Actual meaning of diffusion layer in context of CMOS.
Sorry, not
For
knowledge
which
about
part
that.
we for a transistor there are three parts: source, drain, and gate.
And
For
get.
which part?
Yeah.
Uh, for which part we use diffusion layer?
And source and drain.
Source and drain. And actually, diffusion layer is a doped region in silicon substrate, which is used
Yeah.
for source or drain. And poly
Yeah.
is used for gate.
Yeah. Generally, poly is used for get. Yeah.
Mm. Okay. What is extension? Poly extension?
Yeah. So suppose when I'm doing layout, poly is I think in routing some issue is come. So in this time I extend the poly means length. Sorry, height of the poly is increased.
Okay. Check it once. It has something more than that. Have you faced congestion in routing
Sorry.
for congestion in routing for analog layout?
Yeah, sometimes I face conjunction of routing because if when we face a space issue, so in this time I'm face a conjunction and try to increase the space.
Okay. And how would you manage?
Generally, try to increase the spacing between block and mouse.
Hmm. Uh, uh, what are the tool you have used for optimization layout?
Optimization layout. Sorry.
Like
I'm not use.
Cadence, Innova, Synopsys, ICC2, or
Generally,
Tempest.
synopsis ICC. Generally, synopsis we use.
Okay. Mm. Can you explain your first project?
Yeah, our first project is in TSMC 3nm,
Mm.
and mm, generally in this project I'm do normal DRC routing and physical verification.
Okay. And what is the flow for physical verification?
Yeah, generally run the DRC int LVS LPS int antenna perk and this. The flow is MSIP verification and DRC
Okay.
in Synopsys 2.
Mhm. And what were the problem you have faced for LVS matching?
Sorry, in LVS matching, what are the problem face?
Huh.
Means generally, in LBS matching, generally short and open and mismatch and parameter error is problem is come.
Okay. And take you have written that also take care of different power requirements. What were that?
Yeah. So generally, if any circuit have a different power, suppose BDD and BDD IO, two different power is present. So in this time, in this time I'm follow different DRC of different annual DRC, different potential. Suppose means uh, different PMOS power BDD and BDD IO is separate of minimum DRC, different at a different potential according to the minimum DRC rule.
Okay. What is the difference between uh, this 3 nanometer, 5 nanometer, like technology, or above 45 nanometer technology?
Generally, poly pitch is different in 3 and 5 and 45. Generally, in 3 nm,
Mhm.
minimum poly pitch is 0.048, and in 5 nm, minimum poly pitch is 0.05 51. Generally, poly pitch spacing is different, and this 2 nm, and some voltage and current is different. Operating voltage and poly length is different. In 3 nm, minimum poly length is 0.003, and in 5 nm, minimum poly length is 0.006. These are the different of 3 and 45. Sorry, 5.
One minute. Uh, this technique, like a 5 nanometer and 3 nanometer, these are submicron technology.
Yeah.
What are the advantage and disadvantage in this technology?
Which technology? Technology.
Hmm. Disadvantage and advantage for this technology.
Sorry, I will not deeply knowledge about submicron.
Okay, in submicron technology, there are DIBL effect and leakage effect
Oh,
and
yeah, yeah.
threshold
Yeah,
condition. Yeah.
drain induced barrier lowering and
Yes.
get to source voltage is minimum.
Hmm. The short channel effect. This problem
Short channel.
uh,
Yeah, yeah.
may faced. Uh, can you design stick diagram
In which circuit?
for NAND gate?
Yeah. Generally, in NAND get two PMOS and two NMOS is present,
Uh,
and is the output equation is Y is equal to A into B bar, and when input A into B, in this case, two PMOS is connected in parallel. Sorry, PMOS is connected in parallel,
mm,
and NMOS is connected in series. So generally, PMOS is connected in parallel and NMOS is connected in series. Sorry, NMOS is connected in parallel and PMOS is connected in a series. Generally, these are the stick diagram of NAND.
uh, this is schematic.
Yeah, schematic and sorry, a stick diagram is
Stick diagram for a layout.
yeah, sorry,
Hmm.
stick diagram of NAND.
Okay. Source to drain. Down. Solve it. Do you know about track in layout?
Yeah, generally in Python and flow track means track is the track in track any metal pitch is fixed. So if we follow track, our routing is easier and no issue to come DRC spacing DRC.
How to measure track?
How to measure track?
Hmm.
Generally, metal metal center to metal center.
Yes. Difference between one metal center to different metal center.
Yeah.
And how to calculate number of track in a standard cell.
Generally, first of all, we need a standard cell height, and
Hmm.
we divide the standard cell height by pitch, metal pitch.
Yeah.
Then we find a number of track.
Yes. So for higher drive strain, uh, do you need fewer track or more tracks?
Sorry, repeat again a question.
For higher drive strength,
Dry
which one
stand.
is need? More tracks or fewer tracks?
Higher drain stand, I think more track is used.
Hmm. In which power consumption is more?
And in higher drain stand, power consumption is more.
Hmm. What are the disadvantage for higher metal layer?
Disadvantage of higher metal layer.
Hmm.
Uh, Generally, higher metal thickness is high and fabrication cost is high and width is high.
Hmm.
Means thickness is high, width is high, and fabrication cost of higher metal is high
Hmm.
as compared to lower metal.
Hmm. And advantages?
Advantages is Higher metal resistance is very low.
Mm. A capacitance is low or high?
Yeah, capacity in higher
Capacitance.
metal capacitance is low.
Mm. So, routing density in higher metal layer?
Uh, routing routing density is also high in higher metal.
No, low. It will be low.
Okay,
Because
okay, sir.
wide spacing.
Oh, okay, 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 yes.
Mm. Mm. For eco, what will be easier to change in higher metal layer or lower metal layer?
In lower metal layer,
Mm.
because in higher metal, high current is flow. That's why
Mm.
echo is come.
Mm. What is coupling effect in analog layout?
Generally, if sorry, generally, if parallel routing is in here, and high speed, high current is flow of this net. So this time, coupling is comes.
Mm. And what is non-uniformity effect?
Sorry, I don't know. What is the question?
A non-uniformity effect.
No, I don't know.
Just check it.
Hello.
Mm. Okay, that's enough for me.
Okay, thank you.
Thank you.